Hi students, now problem number 2 in the exercise. A cylinder of length 1.5 meter and a diameter 4 centimeter is fixed at one end. A tangential force of 4 into 10 power 5 Newton is applied at the other end. If the rigidity modulus of the cylinder is 6 into 10 power 10 Newton per meter square, then calculate the twist produced in the cylinder. Now you can see here, this is a metallic cylinder whose one end is fixed to the wall and the other end is free end. At the free end, a tangential force, just like using a spanner or a wrench, we turn the rod so that a tangential force is acting at the other circular face of the cylinder. Now, through how much angle it will twist, through how much angle the twist will be produced. For this, the given quantities I have summarized here. The diameter of the rod is how much? 4 centimeter, that is 4 into 10 power minus 2 meter. So the radius must be what? 2 centimeter. Then the force, tangential force is given 4 into 10 power 5 Newton. Then this is called as the rigidity modulus or shear modulus. Okay, shear modulus is 6 into 10 power 10 Newton per meter square. So this is the twist or angle of shear, shearing strain. Okay, this has to be determined. Now the diameter divided by 2 gives the radius, and the radius of the circle is 2 centimeters. So what is its area can be found first. So area A is equal to pi r square. So this is 3.14 into r square is 2 into 10 power minus 2 the whole square. So the area of this circular face is equal to 3.14 into 2 square is 4 into 10 power minus 2 whole square is 10 power minus 4 meter square. Okay, now the rigidity modulus eta is equal to F by A. Tangential force per unit area, this is called as the shearing stress, divided by shearing strain is the angle of shear. So this is equal to what? F divided by A into theta. Now I need to find only theta. So I take theta to the left hand side and this eta will come to the right side. Okay, or theta is now equal to F divided by eta into A. So now we will substitute for F is equal to 4 into 10 power 5. So this is 4 into 10 to the power of 5 Newton divided by eta is 6 into 10 power 10. So this is 6 into 10 power 10 into area. Area is 3.14 into 4 into 10 power minus 4. Now this 4 and 4 can be cancelled first. Then all these 10 powers can be shifted up. So theta is now equal to 10 power 5 multiplied by this 10 power 10 comes up as 10 power minus 10 into 10 power minus 4 will come up as 10 power 4 whole divided by 6 into 3.14. So 6 into 3.14. Okay, now let us use the calculator. So 6 multiplied by 6 into 3.14. So this is equal to 18.84. So this is equal to, now 10 power, if you adjust means 5 plus 4 is 9, 9 minus 10 is minus 1. So this is 10 power minus 1 divided by 18.84. So this is 1 by 18.84 into 10 power minus 1. So this is 1 divided by 18.84. 18.84 and this is equal to 0.053. 0.053 into 10 power minus 1. So one more decimal place has to be shifted, okay? Therefore, theta must be equal to 0.0053. So 0053. Now this is the twist. Twist is nothing but the angle of shear, is it not? That is the shear. So theta is equal to 0.0053 is the answer. So what we did first, from the radius we found the area of the circular face, then force per unit area, okay, divided by the angle of shear, that is equal to rigidity modulus. We substituted and we have derived the value for theta as 0.0053. I hope you must have understood well. Fine.